Alright, this video is going to focus on graphing logarithms. So we have our parent function f of x equals a times log base b of x minus h, and inside the logarithm plus k. As usual, the a will control vertical stretches or shrinks, and also reflections over the x-axis if it's negative. The h is going to cause horizontal shifts, and the logarithm's going to have a vertical asymptote where the argument inside is going to be equal to 0. So where x minus h is equal to 0, we'll have a vertical asymptote. K controls vertical shifts up and down like before. If your base is between 0 and 1, it'll be decreasing. If b is greater than 1, it'll be increasing. And then you're going to have a vertical asymptote in both versions. Right? So let's do an example. Well, first I'll give you a little bit of guidelines. Graphing logs. Write an exponential form, and then use values for the y when making your table. So most of the time we use x's for constructing our table, but for graphing logs it's a little bit easier to pick values for y when you've written your log in exponential form. And then a lot of times it'll be easier to graph by translations than doing this when you have quite a few translations going on, maybe a horizontal and a vertical translation. I'll show you an example where it might be a little bit more cumbersome. Alright, so we're going to start off with graphing a basic logarithm. F of x equals log base 2 of x. And we've actually graphed this already as the inverse of the exponential 2 to the x. So first thing I want to do is I want to write it in exponential form. Remember, f of x is the same thing as y. So your base is 2, your exponent is y equals x, and that's what I'm going to make my table. So x is equal to 2 to the y, and then I'm going to pick values for my y here. Let me use my highlighter. I'm going to pick values for my y, and it's going to look like the table we've done a bunch before. It's just that the table's reversed. So we'll pick negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, just like before. And we'll go ahead and draw in our tick marks, and then we can go ahead and graph this. And this one has an asymptote at x equals 0. Remember, your exponential function had an asymptote at y equals 0, so logs and exponentials are inverses, so you switch the x and the y. So instead of y equals 0, we have x equals 0. And then we can go ahead and connect our dots, and that's f of x equals log base 2 of x. Now I think what we'll do is we'll graph the exponential, or its inverse, which is 2 to the x. So all that does is it just you switch your x and y, switch your x and y, switch your x and y, and that's how we come up with those points. And we've already graphed the exponential function 2 to the x before. Okay, and then it has a horizontal asymptote, y equals 0, and then we, as before, they're going to be reflections of one another over the line y equals x. Okay. Now what I'm going to do is I'm going to list the domain in the range of f. So the domain is 0 to infinity, and the range is negative infinity to infinity. So the lowest it goes is negative infinity, and it's going to increase to positive infinity. The inverse function just switches the x and the y. So the domain is the variable x, all valid x's, and the range is all valid y's. So the inverse just reverses them. So the domain will be negative infinity to infinity for the exponential, and the range would be 0 to infinity. So you see that the domain and the range are reversed, and the range and the domain are reversed for the function and its inverse. Alright? So remember, this is what your logarithmic function looks like. And so we can do translations of it. So let's do an example. Y equals log base 2, x minus 3 minus 4. So remember this point right here, you kind of look like this. Okay. Now what the minus 3 is going to do is it's going to shift this 1, 2, 3 over. So we're going to move 3 over. And then the 4 is going to shift us down 4. 1, 2, 3, 4. So we're going to be down here as a vertical asymptote. Vertical asymptote was originally over here at 0, so that's going to be moved 3 units over here. And then the same shape here would be my transformation, or translation. So over 3 and then down 4. Now I'm going to show you how to do this with kind of my guidelines. It's going to be a little bit trickier to do. Not too much more, but the table is going to be kind of a pain to construct. So if we know the translation, then just moving the points over and down would work out. But we can show you how to do this. Maybe you don't remember what the original function looks like, so but you do remember the guideline. Okay, and we'll end up seeing that somewhere in here is where we're going to have that point, and it's going to look something like that. All right. So in order to put it in exponential form, we have to isolate the logarithm first. We're going to add 4 to both sides. And then I'm going to use the definition of log. So the base is 2. Logs are equal to its exponent. So exponent is y plus 4. And that's going to equal x minus 3. And then to make this as easy as possible, we're going to isolate the x. Okay. And then we're going to make our table, and we're going to plug in values for the y. Okay. All right. So I went ahead and said that when y is negative 3, x will be 5. So if we do that, we'll have 2 to the negative 3 plus 4 plus 3. Well, that's going to be equal 2 to the first plus 3. So that gives me the 5. Okay, then I'm going to plug in negative 2. 2, that's not a very good looking 2. Let's try again. 2 to the negative 2 plus, no, we're having trouble doing 2, so let's try again. To the negative 2 plus 4 plus 3, going to equal 2 squared plus 3. There's 4 plus 3, there's the 7. So what I'm noticing here is the x values are getting kind of larger. 7, I don't know if I'm going to have enough room. 1, 2, 3, 4, 5, 6. Here's 7 right there. I don't know if I'm going to be able to go a lot farther than that. So I'm going to go kind of in the reverse, and as I construct the table, that's going to help guide me with the values I pick for y. So if I pick negative 4, I'm going to have 2 to the negative 4 plus 4 plus 3 will be 2 to the 0 plus 3. And remember, 2 to the 0 is 1, so this is going to give me should give me a value of 4. All right, I'm going to get this stuff out of the way here. Should pick a larger eraser. All right, and then because I'm out of real estate, we're going to go ahead and pick in some more. And I'll give you an example of one of these. Let's say I do the negative 6. So I have 3 to the negative 6 plus 4. I'm sorry, it's not a 3, it's a 2, isn't it? Let's try again. 2 to the negative 6 plus 4 plus 3 equals 2 to the negative 2 plus 3. Well, that's going to be 1 over 2 squared, or 1 over 4 plus 3. So it'll give me 3 1/4. So it looks like I'm going to start approaching my asymptote of 3. And similarly, we can get those other values on the table there. I can get this value and this value in a similar fashion. So let me get this stuff out of the way. All right, now I got my points, so I'm ready to go ahead and plot some of those points, I think. I'm going to go ahead and plot all those points in. I'm going to mention again, we said it was right 4 and down. I'll have it backwards, don't I? Let me fix this. I don't know what I was thinking when I wrote that. Let's try again. So how many did we go to the right? We went to the right 3, and then we went down 4. Excuse me. I don't know what I was thinking when I wrote that stuff down. Now, the original vertical asymptote was at x equals 0, so I'm going to shift that over to the right 3. Alright, so let's go ahead and plot in all our points. I think I'm going to try to do them in red here so they show up a little bit over here. Alright. Now, there's a graph down there in red, and I mentioned at the beginning that we could have done the same thing if we moved this point right 3 and then down 4. And we could draw in our original function, logarithmic function. So here we go, right 3 and then down 4, and we could have done translations if we had graphed the original log base 2 of x. There's another way of getting at it, and maybe that's a little bit faster for you if you want to do that way. Or you can just put it in exponential form, and then you'll just have to deal with this a little bit. It's not terribly difficult, but you might have to play around a little bit with making your table. Now the domain of this is it's shifted to the right 3, and then the range is still low to high, so negative infinity to infinity. Okay, so that's with the transformation. You can move it left or right, up or down, reflect it, that kind of stuff. And what we've done so far is just with bases that are 2. You might do bases of 3 and 10 and that kind of stuff, but let's look at a base that is a fraction, like maybe a half. So same procedure. We'll put it into exponential form. So the base is 1/2, the exponent is y, and that's equal to x. And then we'll make our table. And you know, you can always do negative 3 to 3, and then if you have to adjust your table, you might have to just pick more values for the y. Okay. So get 1/8, 1/4, 1/2. So if we pick those values for the y, 1/2 cubed is 1/8, 1/2 squared is 1/4, etc. And we'll go ahead and plot those points in. We have the vertical asymptote, x equals 0. The domain is all positives. Oh, we didn't put the range in. Why don't we put the range in? Range is high to low, or low to high, so it's going forever to negative infinity, and goes all the way up to infinity. So remember I said it was going to be decreasing if the base was less than 1, between 0 and 1. And there you go. There's graphing logarithms.